Self-driving cars, human-like voice assistants, ICE that beat world champions at complex games. What do they have in common? They all learned these superpowers through deep learning. Car video game. Today, we're uncovering why deep neural networks are a game changer in AI. Hi everyone, welcome back to the AI Universe series on DSN. In our fourth video, we're focusing on deep learning, which you can think of as the powerhouse approach that's propelling most of the advanced AI breakthroughs today. If you've heard the buzz around deep learning but aren't exactly sure how it's different from regular machine learning, you're not alone. We'll clarify what deep learning means, how it builds on neural networks, and why adding layers can make such a difference, and explore some jaw-dropping applications, from vision to natural language. Plus, if you're excited to learn deep learning yourself, we'll outline a learning path for that too. No PhD required, we'll keep it beginner-friendly. Let's dive deep. Magnifying glass robot. What is deep learning? Deep learning is essentially a subset of machine learning that uses multi-layered neural networks to learn from data. 16. The word deep refers to the number of layers in the neural network. A deep network has many layers, dozens, even hundreds in cutting-edge research models, stacked on top of each other. These multiple layers allow the network to learn data representations in a hierarchical fashion, from low-level features to high-level abstractions. In simpler terms, deep learning models can learn extremely complex patterns by gradually building up understanding through many stages. To contrast it with traditional machine learning, earlier ML models often relied heavily on feature engineering. Human experts would decide the important features to feed into an algorithm. For example, if we wanted to classify images of birds versus airplanes, an expert might suggest features like has wings, or specific shape measurements. The ML model, say a decision tree or an SVM, would then use those features to make a prediction. With deep learning, the approach is different. You typically feed in raw data, like the pixels of images, or the raw audio waveform for speech, or the raw text for language, and the neural network itself discovers the useful features during training. 12. Each layer of the network extracts a higher-level feature from the layer before: edges, right-pointing arrow, shapes, right-pointing arrow, object parts, right-pointing arrow, whole objects. In the case of images, for example, 11. This automatic feature extraction is a huge advantage of deep learning. 17. It means we don't have to explicitly code domain-specific knowledge. The model can learn directly from the data, given enough examples and a suitable architecture. Another hallmark of deep learning is its ability to handle very large and complex datasets. Traditional algorithms often plateau in performance as data grows, but deep neural networks tend to get better with more data, assuming you can also grow the model and have the compute power. They can capture subtler patterns if you feed them millions of examples. This is one reason why deep learning became practical and popular in the 2010s. We finally had big data and powerful GPUs to train big networks. The results were dramatic. Tasks that seemed beyond computers suddenly became feasible. For instance, consider image recognition. Before deep learning, the best algorithms had error rates that were okay but not on par with humans. With deep learning, error rates were cut by more than half, in some cases, 18. In speech recognition, deep models achieved human-level accuracy in transcribing phone calls. It's like these deep nets unlocked a new level of performance because they could model the world in more layers of detail than before. Key components of deep learning. Deep learning models, at their core, are neural networks with many hidden layers, but there have been some tweaks and components that made training them effective. Activation functions. Choosing the right activation in deep networks was crucial. Earlier neural nets used simple activations, like sigmoid, but deep networks started using ReLU, rectified linear unit, which is simple, outputs 0 for negative values and linear for positive, but helps mitigate the vanishing gradient problem, allowing training of deeper layers. Layer types. Besides the convolutional and recurrent layers we discussed in the neural networks video, deep learning architectures introduced things like pooling layers, to reduce dimensionality in CNNs, or attention mechanisms, in transformers, allowing the model to focus on relevant parts of input, revolutionizing language models. The transformer architecture, for example, which is deep but eschews recurrence, has become the foundation for many state-of-the-art models in NLP, like GPT series, due to its ability to handle long-range dependencies with attention. Regularization techniques. Deep nets can overfit if they have too many parameters. Techniques like dropout, randomly dropping some neurons during training to force the network to generalize better, were introduced to keep deep learning models from memorizing the training data. 1918. This helped improve performance on new, unseen data. Optimization advances. Training very deep networks was hard initially because of issues like vanishing gradients. New optimization algorithms, like ADAM, an adaptive learning rate optimizer, and practices, like batch normalization, which stabilizes the distribution of inputs to each layer, made it feasible to train networks with dozens of layers. Think of it as making the learning process smoother and more robust for deep stacks of layers. Deep learning in action. Notable applications. The proof of deep learning's power is in what it has achieved. Here are some high-impact applications and breakthroughs powered by deep learning. Computer vision mastery. We touched on this, but to emphasize, deep CNNs have achieved superhuman accuracy in some image classification tasks. They've enabled self-driving cars to interpret camera feeds in real time, identifying pedestrians, other cars, traffic lights, signs, lane markings, etc. A self-driving car's perception system is essentially a deep learning model, or a collection of models, parsing visual data and even lidar data to understand the environment. Another example. Deep learning is used in medical imaging to detect cancer from MRI or CT scans. In some studies, a deep model could catch early signs of tumors as well as human radiologists, acting as a diagnostic aid. Natural language processing, NLP. Revolution. With deep learning, especially since the advent of transformer-based models, NLP has leapt forward. Language translation got a boost. Google's neural machine translation uses deep LSTM, transformer models to translate languages in a way that captures more context and nuance. Speech recognition and voice assistants, like Siri, Alexa, rely on deep recurrent or transformer models to understand and generate speech. And notably, large language models like GPT, the model behind ChatGPT, are deep learning models with billions of parameters trained on massive text corpora, enabling them to generate human-like text, answer questions, write code, etc. This was science fiction a decade ago. Now it's a product of deep learning. AlphaGo and Game Ice. When DeepMind's AlphaGo defeated Go champion Lee Sedol in 2016, it was a watershed moment. AlphaGo combined deep CNNs with reinforcement learning and tree search to evaluate Go boards and choose moves. The neural nets were trained from millions of positions, including games it played against itself. This wouldn't have been possible without deep learning to approximate the extremely complex problem of Go. Since then, similar deep RL approaches have mastered games like StarCraft, and even generalized game-playing agents have been created. Creative AI, generative models. Deep learning opened the door for generative AI, our next video's topic. Models like GANs, generative adversarial networks, can generate startlingly realistic images, from creating faces of non-existent people to imagining new product designs. Variational autoencoders, VAEs, and diffusion models are other deep learning-based generative approaches that can create art, do style transfer, make a photo look like Van Gogh's Starry Night, for example, or enhance image quality. On the text side, deep models write news articles, poetry, and even computer code. We even have deep learning models that can generate music or deepfake videos. All of these are built on deep neural network architectures, learning the patterns of a domain so thoroughly they can produce new content that fits those patterns. Predictive analytics. Many businesses use deep learning for forecasting and trends prediction. For instance, predicting stock price movements or economic indicators. Some hedge funds use deep nets on massive sets of financial data, or predicting customer churn or demand in supply chains. While simpler ML models can do forecasting, deep models can sometimes find complex nonlinear relationships and seasonal patterns better, especially when there's a lot of data or multiple signals. It's important to note that while deep learning has delivered incredible results, it often comes with trade-offs like needing large amounts of data, lots of computation. Training a state-of-the-art model can take days or weeks on specialized hardware, and sometimes being a black box, not easy to interpret why it made a certain decision. There's a whole subfield called explainable AI trying to peek into these black boxes. But for many tasks, the performance gains have been worth it, and deep learning models have become the go-to solution. As one famous quote sums it up, AI is basically becoming deep learning at scale. Learning path. Getting started with deep learning. If you followed along the previous video on neural networks, you're already on your way. To specialize further in deep learning, here's what you can do. 1. Foundation first. Make sure you understand neural network basics, layers, activations, overfitting, etc., as covered earlier. Deep learning is essentially scaling that up, so solidify your understanding there. 2. Dive into deep learning frameworks. As mentioned, frameworks like TensorFlow, Keras, and PyTorch are your best friends. By now, you might have tried a basic example in one of them. Keep going. Try building slightly deeper networks for different tasks. For example, use Keras to build a CNN for classifying images, perhaps CIFAR 10 dataset of tiny images across 10 categories. This will teach you about convolutional layers, pooling, etc. Then maybe try a simple RNN for a sequence problem, like predicting the next character in a text string. Working through these examples step by step, many tutorials are out there, will increase your confidence. 3. Structured learning. Consider following a more structured deep learning curriculum. The deep learning AI specialization is a great deep dive. It covers CNNs, RNNs, even sequence models and some deployment tips. There are also free resources like the Fast.ai course, which covers cutting-edge techniques but in a very accessible way, using a top-down teaching approach. 4. Build a portfolio of projects. Deep learning has so many avenues. Pick a project that genuinely interests you. Love music? Try a project generating music or classifying genres via audio spectrograms and a CNN. Into healthcare? Experiment, carefully, with open datasets, on a project like classifying chest X-rays. There are public datasets for pneumonia detection. Like games? Try coding a deep Q network that learns to play a simple video game. OpenAI's Gym has environments for this. Each project will likely require you to learn new techniques. Maybe one project forces you to learn about data augmentation, tricks to expand your dataset. Another might expose you to transfer learning, using a pre-trained model on a new task, which is hugely useful in deep learning to avoid needing insane amounts of data. 5. Use pre-trained models and AMP. Transfer learning. One hack to do impressive things as a beginner: leverage the work already done by the community. For example, You can download a pre-trained image recognition model, like ResNet or VGG, which are deep CNNs trained on huge image datasets, and use it to classify images in a domain where you have limited data, with some fine-tuning. Learn about libraries like Hugging Face Transformers for NLP, which let you use state-of-the-art models with just a few lines of code. This way, you can experiment with powerful deep learning models without training them from scratch. It's a great learning experience to see how these models perform and how to adapt them. 6. Community and research. Keep an eye on the latest developments. Deep learning is evolving quickly. Even if you don't understand research papers fully, reading the summaries or articles about them can give you insight into where things are heading, e.g., new architectures like transformers dominating NLP, or how GANs are being improved. Engage in communities. There are dedicated deep learning forums and discords where people discuss problems and breakthroughs. And if you can, find a study group or a friend also learning deep learning. Teaching each other or just sharing progress can keep you motivated. 7. Hands-on with hardware, optional but fun. If you get serious, you might even play with hardware like a GPU or Google Colab, which offers free GPU time to train bigger models. It's satisfying to watch your deep net's accuracy improve epoch after epoch. And if you lean into the engineering side, learning how to optimize training, handle big data, etc., can be valuable skills. Deep learning can feel daunting because it has so many layers, literally and figuratively, but don't be discouraged. With each concept you learn, say, how a convolution works, or what attention means in a transformer, the picture becomes clearer. Start with small steps and gradually challenge yourself with more complex tasks. Remember, deep learning is a tool, an immensely powerful one, and like any tool, mastery comes with practice. But even at the beginner level, you can do some really cool things, like classifying images or generating simple text, which will make all that learning feel worthwhile. Conclusion and AMP. CTA. Deep learning has truly transformed what's possible with AI, enabling breakthroughs in vision, speech, and creativity that were unimaginable a decade ago. And it all boils down to stacking simple neuron layers into very deep networks that can capture incredibly rich patterns from data. We hope this overview demystified deep learning for you and maybe even inspired you to try building a deep model yourself. The world of AI is moving fast, but with the foundations you're building, you can be part of this exciting journey. In our next and final video of the series, we'll talk about generative AI, the branch of AI that creates, from text to images to music. It's a hot topic, and for good reason. So don't miss that. If you found this video helpful, please let us know. And as always, subscribe to DSN for more videos and drop your questions in the comments.